Not necessary. It's all here.
The distance between two consecutive crusts in a consecutive crust wave is 5 centimeter. Okay. Distance between consecutive crust means lambda. Lambda is equal to 5 centimeter. Good. If two complete waves pass through the point per second, 1, 2. Two waves are passing through per second means what? Frequency is 2 hertz. Okay. Velocity wave V is equal to nu lambda. Because 5 is in centimeters. This is all centimeters. Answer is A, ninth one. Ninth one. 10th one. Sound will travel from air to water. Which of these remains constant? I told you already. When wave travels from one medium to another medium, frequency remains same. So I repeat once again, V is equal to nu lambda. Velocity depends on medium, frequency depends on source. So when medium changes, definitely velocity will change. Because source is same, frequency won't change, lambda definitely change. Because in a 3-variable equation, you can't change only one variable. One changes, definitely other one must, any one must change. Okay, both may change, is a different story. But that's the rule. Answer is frequency remains same. Distance between successive compression and rarefaction is 1 meter. Wait. Distance between two successive compressions or rarefactions is lambda. But successive compression rarefaction is lambda by 2. Right? Right. That means lambda by 2 is equal to 1 meter. Lambda is equal to 2 meters. Right. Velocity is only 360. V is equal to 360. What they want? Frequency. Nu is equal to V by lambda. 360 by 2. How much? 180. You try to write the minimal amount of working over there. Answer is A. 12. Frequency of tuning fork 250 hertz. Velocity of air something. Distance traveled by the sound during the time which the tuning fork completes 32 vibration. Okay, what I'll do is that frequency is equal to 256 hertz. And the time period T will be equal to 1 by 256, obviously. And time taken to complete 32 vibrations. So that I'll call it as small t because I can't take capital T. Capital T is time period. That is equal to, what is the value? 32 by 256. 32 by 256. Okay, we'll stop it here. Let us continue. Okay. The distance traveled by the sound. Okay. Distance is equal to velocity into time. What is velocity? 344 into 32 by 256. It's a simple matter of mathematics. Okay, 32, how many times? 2, 8, 10, 10s, 8s. Okay. 43. Correct. Answer is 43. 43 meters. Okay. So answer is B. Bravo. 13. 13. The number of waves contained in unit length of medium is called. A small problem here that you need to understand is a little different concept. Let us take the equation of wave. Y is equal to A sine omega t minus kx. Y is equal to A sine omega t minus kx. Omega is equal to 2 pi by t and 1 by t is equal to frequency nu. This part is fine. If you take this part, k is equal to 2 pi by lambda. That's it. But see, if you compare omega t, k lambda, check it, 2 pi is comparable. And one more comparison is also there. Suppose if you take it like this, distance between these two is lambda, time interval between these two is t. Sir, what is this? Actually, there are totally two graphs you can take in a wave. There are totally two graphs you can take in a wave. 1 minute. Just a minute, I'll make it. Right. This equation, this diagram is there, assume. Okay. Now my doubt is that what is this length? You need to understand that suppose if it is x versus y graph, this will be lambda wavelength, because on x-axis we have x. But if I take the same graph and instead of writing x, if I write t, the same thing will be time period t. Sir, I don't understand why we have two graphs. I'll tell you. This is a single particle displacement. I already told you. Let us go back to 1 minute. The diagram. Yeah. We take it. If I don't care about entire string, I care about only one particle, and I write the graph between this particle, assume. So the particle goes up and down, oscillates, right or wrong? So there are totally two different graphs, x and t graph 1, x and y graph 1, y and t graph 1. So this is oscillation of a single particle. This is the entire string, how it will be. So there is complete similarity between this and this, lot of similarity. Of course, there is a huge difference also. One is based on time, other one is based on distance. So if you compare that, 2 pi by t, 2 pi by lambda, good. Because this length is lambda, this length is t, right? What final conclusion? There must be something 1 by lambda is called. 1 by lambda is called as wave number.
Wave number.
New bar we use. Generally, they'll use in chemistry. Physics, we don't use that. But for the sake of memory or knowledge, you can take it. It's B answered. It's wave number. Okay. (14) Which of the following expression is that of a complete harmonic progressive wave? A sin omega t is oscillation. B pata, we don't know. So you can't conclude B is right answer or wrong answer. But if you go to C, definitely you can conclude it's a progressive wave. Because we already know that same form we are using, y is equal to a sin omega t. So C is definite answer. B you don't know. D definitely no. Okay. So answer is C. Standard equation. 15. The equation of propagation of wave propagation with velocity 30 meter per second and having frequency 110 hertz amplitude. Okay, fine. Y is equal to a sine omega t minus kx, or I can write a sine, what is omega? 2 pi nu t. What is k? 2 pi by lambda x. You can write like this, or if you want, you can take 2 pi common, right? So in this question, they took 2 pi common, so we take 2 pi common. Let us write the data. Amplitude is 0.05. 0.05 into sine 2 pi, I take common. Okay. Frequency, what is the frequency? 110 hertz minus 2 pi by lambda. Wait, lambda theriyadane, but velocity is given. V is equal to 330. nu is equal to 110. So lambda is equal to V by nu. 3. So x by 3. 2 pi I took common. This is the equation required. It must be given somewhere. Okay. Once I look into the answer, I got a better sense, because they said a wave, but they never told positive x or negative x, right? So I feel plus or minus is better because A is right, B is also right, but C is much, much better. Sir, if it is multi-correct, what to do? Mark A, B, C. Single correct, only C. C is a more appropriate answer. 16. A wave is represented by equation. Okay, right. Let me write the equation. Y is equal to 7 sine 7 pi t minus 0.04 x plus pi by 3. See why this question is given. There are sometimes some deviation from the equation. Whatever we learned, y is equal to a sine omega t minus kx. One of the deviation I can say like y is equal to a cos omega t minus kx. Definitely this also, because sine and cos are what? Harmonic functions. So sine means the particle starts from equilibrium 0 and go to maximum and come back. Cos means particle starts from extreme and oscillates like this. So we can use both sine and cos. That's okay. And sometimes like this also. Y is equal to a sine kx minus omega t. Sir, kx, yeah, 100% it is allowed. You can use it. Okay. So deviations will be there, but here little different type of deviation. What is that? If you recall SHM, y is equal to a sine omega t is SHM, but generally we take plus phi. What is this plus phi? It will decide initial phase. That means initially where the particle is starting. If phi is 0, it equilibrium. Phi is equal to pi by 2 or 90. It starts from extreme like that. I discussed in SHM. So what's the meaning of it? This phi extra will add what? And a small thing that where the particle starts. But still it is SHM only. That's what I explained in SHM. Same thing here. It's a wave, but it has some initial phase, all that. Ignore. Now remaining everything as usual. What are the, right? Speed. Now V is equal to nu lambda, I told you. I do small modification. Nu is equal to 1 by t lambda. That is equal to what I do, I multiply with 2 pi with numerator and denominator. So 2 pi by t omega. Denominator, you look into that. 2 pi by lambda. What is the value? 1 this k. So you can write V is equal to nu lambda if you can mug up omega by k. I think I gave it to you already. V is equal to nu lambda. No, I haven't given. Take this words. V is equal to omega by k. That also you can take. Or else by taking omega and lambda or omega and that k, you can calculate the required things and you can make it. No problem. But omega t is easy. Omega. What is omega? 7 pi. By k. What is k? 0.04. Right? So it will be, what is the value? 700 pi by 4.
75.
Yeah, 175 pi. Answer is A. 17. The equation of wave. Y is equal to 5 sine t by 0.04 minus x by 4. Okay. That's it. Find the maximum velocity of particle. Oh, be careful. It's not velocity. Maximum velocity. Let us go back to SHM. Y is equal to A sine omega t, right? Suppose if you want velocity, V is equal to A omega cos omega t is velocity. And maximum value if you want, cos omega t will be 1. So V max is equal to A omega. Sir, can I use same thing here? 100% yes. Because although wave is there, in case of wave, we have multiple particles on a string. If you want, I can go back and explain that, it will be better. What is wave? We have a string, multiple particles are there, but if you look into one single particle, it is SHM only. So almost Liouville property of SHM will come. Okay. Right. Now we can use A omega. V is equal to A is 5. What is omega? 1 by 0.04. That is equal to 500 by 4. 125. Wait. I need to use units also. Centimeters. 125 units are centimeters given, check it there. So it is centimeter per second. 125 centimeter per second or 1.25 meter per second. Clear? Answer is Charlie C. 18. Okay. A transverse wave described by equation y is equal to y naught into sine. Actually, they haven't given a bracket, but ft minus x by lambda. Straightforward equation they give. The maximum particle velocity is equal to 4 times the wave velocity. Maximum particle velocity here, that is A omega, is equal to 4 times the wave velocity. Wave velocity is nu lambda. Right or wrong? 4 times the wave velocity is equal to maximum particle velocity. Fine. Now substitute the data. A is y naught in this equation. Then A, what is omega? Omega is 2 pi f here, right? 2 pi f is equal to 4 times frequency. Frequency is f only. Lambda is lambda only. Yeah. F is getting cancelled. Yeah. F is not an option. What they want? Lambda equal to. That implies lambda is equal to pi y by 2 or y naught by 2. One more thing I did. 2 times it gets cancelled. So pi y by 2. Answer is B. Bravo. Now we discuss a new topic called as standing wave. Right. I already told you a little bit about standing wave. Lot of things to discuss. Lot. Okay. Standing wave already discussed. How standing will be formed is that two waves are traveling in opposite direction. Superimpose. They will produce, and the key requirement is they must have same frequency, wavelength and all. Of course, once frequency is same, wavelength must be same. Reason? Definitely they are traveling in same medium. Yes or no? If medium is not same, they can't superimpose. When medium is not same, they can't superimpose. So medium, two different medias, they can't join. Na? Okay. So medium is same. Frequency is same. Definitely lambda will be same. So we discussed a little bit about it, but let us start with the math of it. Let us take two waves. Y1 is equal to A sine omega t minus kx, and y2 is equal to A sine omega t plus kx. Two waves I'm taking. If you want resultant y is equal to, simply add them y1 plus y2 because they're moving in the same medium. They superimpose. So they add. I can take direct step right now. I'll take A common. It will be sine. Wait. Why should I write everything? I can cut and paste. Na? A sine omega t minus kx plus this. So I can say sine c plus sine d. Wait, I took it as common. Na? Sine c plus sine d, that is equal to sine c plus sine d, 2 sine c plus d by 2. If I add c and d, plus kx minus kx gets cancelled. Omega t plus omega t, 2 omega t. So c plus d by 2 into cos c minus d by 2. Omega t minus kx minus omega t minus kx, because I took in. Then you will end up at minus 2 kx by 2. Because plus omega t, this omega t gets cancelled. Got it? Sin c plus sin d formula. Directly I'm using. No, few things we can do. Minus minus gets cancelled. And you know, cos of minus theta is equal to cos theta. Why, sir? It's there in mathematics. Cos is what? Even function or odd function? Even function. So that's the case. Now, if I simplify this one, I'll write like this. 2a cos kx. I'll write in a bracket. Sin omega t. See, generally, wave equation will be x minus vt. 1 minute. Yeah, observe. The body will go like the disturbance will go like this. Wave equation is y is equal to f of x minus vt. Some x minus vt formula. What is that wave equation? It should be there. Okay. But here x minus vt or x plus vt? X minus vt, x plus vt is there. Here on the mother, x is there, t is there. But still, x minus vt form is not there. So it loses the kind of wave property, I can say. And I can say like this. This entire thing, if you take it as some constant, then some constant to sine omega t, it's SHM. So it's just SHM. And what is the special property of this SHM is that the amplitude, this is amplitude part, right? The amplitude part will be, depends on multiple factors. X value means what? Suppose if x is equal to 0, the amplitude will be 2a. X is equal to, actually speaking, we have to take kx here. Okay, fine. X is equal to exactly lambda by 4. What will happen? Check it. Cos kx we have to calculate. Cos k is what? Tell me, 2 pi by lambda. Now what happens? Lambda gets cancelled. 2 how many times? 2 times. What is pi by 2? 90 degrees. Cos 90 is how much? Tell me. 0. That means the particle doesn't have any amplitude. Means what? The particle is not moving at all. So when it is 0, it is having 2a. Of course, when cos is 0, it's maximum. So at 0, particle is vibrating with maximum amplitude. And at lambda by 4, it is oscillating. No, it's not oscillating at all. If you can solve it, then you will understand lambda by 2, again 2a, 3 lambda by 4, 0. So what happens is that the amplitude of the particle, in this case, I'm telling you, assume this is the origin. This particle has maximum amplitude as I go forward at a distance of lambda by 4. That particle has 0 amplitude. Then if I further go to the point of what, tell me? Lambda by 2, again it has maximum amplitude. 3 lambda by 4, 0 amplitude. Lambda, this is the starting point, na? Lambda, exact lambda distance we have 0 again. So the amplitude keeps on changing with distance. Are you able to understand? Amplitude keeps on changing with distance. So this is Rustic Halliday Crane says that, sorry, Walker. Rustic Halliday Walker says that it's not a what? This is not a wave. It's simply oscillation with different amplitudes. That's also one way correct. But internally 2 waves are there. And in terms of brief idea of energy, first wave will take energy forward. Second wave will bring it backwards. Net energy transfer is how much? 0. Net energy transfer is 0. That's what you need to understand. This is a standing wave equation. One small point I would like to tell you, that suppose if at all it's given 2a sine kx sine omega t. Is this standing wave?
Yes, sir.
Yes, it's a standing wave. But only difference is what, tell me? Cos kx means it starts maximum, go to 0, 0 to again maximum, like this it will come. Right? It goes on. Okay. But starting point is like this because at x is equal to 0, we have 2a. Check it. X is equal to 0, cos kx is 2a. But if it is sin kx, what the difference it will come? Can you pick it up?
Yes, sir. So origin.
Yeah. It starts from origin. Yeah. Like this it will be. So if it is sine, what happens is that simply node and antinode positions will change because of sine and cos. And there is no serious change in what? The pattern. The pattern is same. There's only small change of lambda by 2 shift is there. That's the only thing. And next thing, instead of omega t, you can go for, okay, sine omega t, you can go for cos omega t also. Equal to, I'll write this is y. This is also y. I'll write another. Reason is this never been equal to this. That's a different thing. Another one also, you can write like this. Y is equal to 2a sin kx or cos kx. You can write anything into cos omega t. Sir, what does the cos omega t will do? When t is equal to 0, sin omega t is 0. That means what? If I take this equation, so this equation, it's like sine, na? So entire string will be horizontal because it starts from 0, it goes up and oscillates like this. So you know very well, sin omega t will start from equilibrium, then it oscillate like this, sin omega t. But what cos omega t will do? It starts from extreme and oscillate. So the difference between sin omega t, cos omega t is simple, where it starts, that's it. So in this case, the string will start from extreme and then oscillate. The previous case, the string will start from equilibrium and then oscillate. No serious difference. Okay. Okay. So you need to understand few things because you need to learn a lot. Everything we'll discuss, but this is node. This is also node. Distance between two successive nodes is how much? Lambda by 2. It's not lambda, lambda by 2. Distance between two successive node and antinode is lambda by 4. That's the first thing.
Sir?
Yep.
Can you draw the graph for third one, sir?
Third one.
Yes,
This
sir.
is a graph.
Third one. Y is equal to 2a sin kx cos
This one.
omega t.
This one.
Okay, sir.
Second and third both are this one only. But
Same.
only thing which will decide, this part will decide where the string starts. Cos means string start from this position and starts vibrating. Sine means it starts from equilibrium, starts vibrating. That's it.
Sir, but cos omega t should be from equilibrium, sir.
Cos omega t equilibrium. How?
Sir, no.
Right. This is what you need to. Lambda by 4. Good. So yeah, this is one thing you need to. Next thing is in phase. You need to understand phase. Okay. Ideally speaking, if I have a particle or GIF image, a particle which is executing SHM, it will be idle. Right now, I can't search it, but let us take it like this. There is a particle which is executing SHM. You need to understand in SHM, there's a concept called as phase. When it is equilibrium, 0 phase. At extreme, it is called as 90 degrees or pi by 2, whatever is comfortable for you. When it comes back to equilibrium, but moving backwards, this is called as 180-degree phase or pi. This will be 270-degree phase. You can take 270 or minus 90 also allowed. And again, when it comes back to equilibrium, it can be taken as 0 or 360. 0 or 360. So this is the concept of phase. You should know that first. Then only we can understand. Assume that I have two oscillations. One oscillation is like this. Equilibrium, extreme, extreme. One more oscillation is like this. Same thing, equilibrium, extreme, extreme. Now, you may have a doubt, sir, if this is 90 degrees, some displacement 10 centimeters. Okay. In the second oscillation also at 10 centimeters, it must be 90 degrees only, na? No. Phase is not decided by the displacement. Phase is decided by the state. So if this is 90, assume that this oscillation is 12 centimeters, assume. Then 90-degree phase will come at extreme. Can you understand this? So what are the conclusion? Phase doesn't depend on amplitude. This has 10 centimeter amplitude. This has 12 centimeter amplitude. Right? Observe. Although it has 10 centimeter amplitude, the other one has 12 centimeter amplitude. But still, phase doesn't care about amplitude. Which state it is. Phase means state. So this is 0 phase. Equilibrium is 0 phase. Extreme means pi by 2 phase or 90-degree phase. Okay, that's the concept of phase. You should know phase very well. Otherwise, whatever I'm speaking next, you may not be able to understand. Okay, right. Let us continue with the standing wave. Observe standing wave. 1 minute. If you observe this, what we can say, situation right now, I freezed it in time. I freezed it. Right? If you observe the particles, see, I can't write it here because if I start writing, it starts moving. Let us take snapshot of it. You do the snapshot. 1 minute. I need to stop it exactly at moment. Yeah, that's the case. So I need to stop it exactly. Exactly means that, it should go to the peak. I'm not able to stop it. I'm not able to stop when it goes to peak, but at any moment you take it. If you observe the particles between these two, check it. Yeah. Every particle reached its peak. Check it. If I take this particle, it reached its peak. If I take the other particle, it reached its peak. This particle also reached its peak. Every particle reached its peak at same time. Check it. Every particle reached its peak at same time. If you're interested, you take a snapshot right now. So every particle on the string is at its peak and it will not go further. That means if you take this particle, it cannot go up to this position, right or wrong. It's at its peak. This is also at this peak. So what's the meaning of it? In case of standing wave, if I speak about wave as a phase, all particles in a loop. What is loop? I'll tell you. A loop, a single loop means node to node. Node to node means node to next node. Because node to node means student may ask like this, sir, I'll take it in this way. This is a node I'll take and I'll take this node. That's not loop. Two successive nodes, I can say. All particles in a loop will vibrate in same phase. Okay, they all be in same phase at any given time. Understood? But if you take the case of other wave, what other wave? Progressive wave. Let us study what about phase. I'll go back 1 minute. Yeah. Observe carefully. This particle, observe, I'll stop it here. This particle is at extreme phase, right or wrong? That particle extreme. But observe the neighboring particle is not at extreme, going to extreme. The previous particle is coming back from extreme. So if this particle is at 0 phase, sorry, a 90-degree phase, this is going to 90. This one is already gone to 90, gone beyond 90. So you can say like this, roughly, not exactly. If I take this one, this is 90, this will be 89 kind of thing. This is 91 kind of thing. Can you understand? So there is no loop first point and no, I can say like this. In a wave, neighboring particles are slightly off the phase. But in a standing wave, in a loop, if you take it, all the particles, the neighboring particles, all are in same phase. Phase is a very important thing to understand. So, particles are in different phase. You may ask, sir, when they come to same phase? See, in case of progressive wave, same phase will come only after lambda. I need to stop it. Observe, if I start from here, I'll get same phase exactly after traveling lambda. That means two particles will be in same phase only after traveling lambda distance. Can you understand? Only after lambda. Neighboring particles will not be in same phase. Okay. But progressive wave, all the particles in a given loop will be same phase. And one more point, if you're interested, you can check it. When it is a positive extreme, neighboring is negative extreme, check it. Similarly, if I take this one, When this is negative extreme, this is positive, this is positive. So I can say particles in neighboring loops are out of phase by pi. Pi means one is at 0, other one is 180, one is at 90, other one is 270, like that. So neighboring particles will be by pi. This is a standing wave, and if you want, you can lot of differences you can write. Basic difference is standing wave will not transfer energy, progressive wave will transfer energy. So this is the thing you need to know about what? Question number 21. Whatever discussion is done based on that only. On stationary wave, all the particles in a region between two nodes, that is nothing but loop, vibrate in phase. Answer is B, straight. 22. In a stationary wave, all particles between two nodes pass through mean position at same time. Observe. Sir, I'm not getting it. Always you have to compare with what? That video, that animation that you saw, na? You have to recall. See, now this particle is passing through origin. Next particle will take, check it. So all the particles are not passing through origin at the same time. One after other, one after other. But standing wave, check it. All the particles in a loop will touch the equilibrium same time. Because obviously they're in same phase. Yeah, correct. So that you can take and we can continue. 22. In a stationary wave, see, stationary wave is nothing but standing wave. Okay, a different name. So at different times with different, no. At same time with different velocities. Sir, why different velocities? This one I'll explain. Just a minute. See, I'm lucky that I'm going through online video, so that what I can I can make I can show you the video, I can explain something. But problem is that in school, when we write it on the board, how can I make it to move? So if I want to indicate a wave, just a minute. How do I indicate standing wave and a progressive wave? Okay, that's what the question is. So answer is simple. We indicate a progressive wave like this, a standing wave like this. How come? This is standing wave simply because at one moment it will be equilibrium, one moment extreme, one moment negative extreme. By taking these three situations, we make the diagram like this. This is a standing wave representation. And this is a progressive wave. Standing wave and progressive wave. Okay. Now, fine. Node and all these things, you node, antinode. That's fine. And you have crust, trough, standard stuff. Good. But at same time, different velocity. Observe carefully. How do you decide particle velocity? Velocity V is equal to A omega. Sir, V is equal to nu lambda. That is wave velocity. I'm asking particle velocity. A omega cos omega t. And maximum particle velocity will be A omega. So let us write V max. If this is the maximum velocity, in which case, standing wave or progressive wave? Both cases. In both cases, particles are executing SHM only. Observe, in progressive wave, every particle has same amplitude. So they will have same maximum velocity. But in a standing wave, this particle has one amplitude. The particle is the antinode has a maximum amplitude, right? So the particle at the node has zero amplitude. Different particles has what, tell me? Different amplitudes. So different amplitudes, different velocity. So when the when the string comes like this, means like entire string comes to the equilibrium, then I would like to make this diagram. Just a minute. I will copy only this loop. I'll do one thing. I'll bring the standing wave below. Then it looks better. Just a minute. Yeah. Good. I'll take the standing wave. Yeah. Now, what we need to. I would like to make the diagram of velocities. If this is this is Vmax and this has zero velocity, somewhere in between velocity will be less and like this. Can you feel it? What the feel? I'll tell you 1 minute. The feel is like this. When the string is at equilibrium, this point is moving with less velocity, little bit more, maximum velocity, less like that. That's what you need to understand. That's what you need to understand. Clear? Different particles are moving with different velocities. Understanding that. So answer is D. 23rd. In a stationary wave, distance between its nearest antinodes is 20. Yeah, lambda by 2 is 20, lambda is 40 centimeters. The phase difference between two particles having separation 60 centimeter will be. Okay, let us take it like this. Repeat, a stationary wave, distance between node and its nearest antinode. Wait, node and antinode is what? Tell me. Node and antinode is lambda by 4, na? Lambda is equal to 80 centimeters. So what's the meaning of it? The distance between node, this is 80 centimeters, right? 1 minute. 30, 20. Lambda is 20, no? Lambda by 4 is 20. Lambda is 80. Okay. Now, the phase difference between particles having separation of 60. Wait. This is 40 centimeter. So, if I take 60 centimeter separation, I'll take it from here. 60 means definitely it'll go to next loop. Two particles in neighboring loops will have what? Tell me. Opposite phase. Sir, definitely it is. Pi, sir. No. Possibility of 0 is also there. You're not getting it. The reason is this length is 40, right or wrong? Node to node will be lambda by 2. That is what? 40 centimeters. Now what I'll do is that I'll take 2 points at a distance of 60, means like this. I'll take it somewhere close to this node. Then I'll go to what? Tell me. Exactly 60. Because this is not 10 or something like that. It is less than 10. So assume this is 5 centimeter from the node. Okay. 5 plus 40, 45. 45 plus 15. What I'm going to get? 60. So the phase of particles which are in next to next loop will be again 0. So answer is 0 possible and pi also possible. So answer for this question is A or C. If you got answer D, you got the answer because of there is a concept called as 2 pi by lambda into path difference is equal to phase difference. That is for progressive wave, not for standing wave, because Different particles will have different phase. Standing wave law, all the particles in loop will have same phase. If you got it, that's the answer. That is a mistake. Okay. Right. What is the answer for 24? Give it to me. 24. Solve. 24 answer is B. Solve it. Okay. And 25? Make it fast. 26. Equation is given. To adjacent node separation, right? We need lambda. Okay. Remember, wave equation y is equal to, or standing wave equation more perfectly, y is equal to a sine kx sine omega t, but it's not a. I recommend you to continue with 2a, where 2a is the amplitude of the particle in a standing wave, and a is amplitude of each wave. Standing wave will have two waves, so a will be amplitude of each wave. That's also good. Now, if you observe the equation given there in 26, what is k value? X by 3. That implies 2 pi by lambda is equal to x by 3. Then I can simplify this. 2 pi by lambda is x by 3. Wait. Pi x by 3, not x by 3. Pi by 3. Mistake. Comparison mistake. Pi by 3. Now, pi gets cancelled. Lambda is equal to 6. Distance between two consecutive nodes will be lambda by 2. No? So the required distance d, let us call it as d, is equal to 6 by 2, 3 centimeters. Quick. 27. Wavelength. Easy to deal with. Right. Compare the equation. I'm making direct step. Kx is equal to 5x. K is equal to 5. That implies lambda is equal to 2 pi by 5 answer. Simplify it, you will get answer. Answer is B. Bravo. B. That's fine.
Here you have to take pi is 3.14, right?
Yes. Sir, can't we use pi is equal to 360 degrees? Pi is not equal to 360 degrees. Comparison law. That if you want to change one angle to other angle, some students may get confused. One angle, if you want to convert pi to degrees, then only you have to use. Otherwise, pi should not be used. Now we discuss wave on a string.
Sir, can you once explain 23rd alone, sir?
Yeah, the point is 40 centimeter distance is there, na?
Yes, sir.
So the lambda is 40 centimeters and they want 60. So I'll do one thing. 10 centimeter left of this node, 10 centimeter right of this node, I'll take. Those two also at what? 60 centimeters only, na?
Yes, sir.
So both are in same phase because adjacent loops will be in opposite phase because this zero phase, this is pi phase, this is again zero phase, right?
Okay, sir.
So
Yes,
it
sir.
can be zero also. That's a problem. Right. Wave on a string. Sir, up to now, what we discussed is not wave on a string. Kana, that is a transverse wave. And wave on a string is transverse wave. So I can say wave on a string is a subset of what? Transverse wave. That's the first thing you need to understand. See, there is a sonometer arrangement like this, it will be, and slotted weights will be there, right? You can take any instrument also, guitar or veena or something, where we don't have these weights. What we have is that string will be there, and you can tie it up with a screw kind of arrangement will be there, which you can make it. So to make the wave to travel in a string, you need to have some tension. Some tension is required. Tension it doesn't work. And generally two supports will be there. In this case, these two supports are called as bridges or knife edge also they say. Bridge or knife edge, both you can say. Okay. So the point is this, the bridge or knife edge will be node because this won't allow it to move up and down. Because it can't move up and down, it's a node. Sir, node and node means it should vibrate like this. 1 minute. It should vibrate like this, sir. I understood that the string has to vibrate like this, right? But need not be. It may not vibrate like that. There may be one more node at the middle. It can vibrate like this also. Multiple ways are there. So all these things we discuss in what normal modes, and we'll discuss that. Anyway, there must be some tension. We take tension as t, and the velocity of wave on a string will be square root of t by mu. What is mu? Mass by length. Mass by length is nothing but linear mass density. Mass by length is nothing but linear mass density. Clear? Linear mass density. Sir, linear mass density lambda. Yes, we are using lambda up to now, but we use because lambda is already taken in waves. That's it. So on a string, the wave will be definitely transverse wave, and it is a stationary wave. It's a stationary wave. And one small problem is that, polarization you don't know, but the word polarization will come in the first question. For time being, ignore. You will understand once you complete light waves, polarization, everything you'll understand. This is the thing first. This is the thing. And all the rules of standing wave is applicable here also, but with a limitation. What are the limitation? Knife edge must be what? Node. So to understand that, I'll give you some data. Just remember that based on that, we'll build up in next class. What is that? Fixed end. Right? A string is there. There is a fixed end. Fixed end must be what? Tell me. Node. Sir, why fixed end is a node? Because it can't move. Free end. Free end. I'll say antinode. You may have a doubt. Sir, I have a doubt. A string is there. One end is fixed, fine. Other end is free. Then when a string with other end free, how it can develop tension? Good question. Assume that other end is a ring. Can you understand this? There is a ring and it is passing through a rod. The ring is just passing through a rod. Let us make it as a thicker one. A rod is there. Now what to do? Concentrate. Ring, I'll use red color. Think you can. I want to get the feel that ring is on the. Now you can see that. Can you see the ring? Ring, the rod is passing through the ring. Can you see that? In this case, what happens is that if you stretch them a little bit, then the string will have tension. But this end is not fixed. It can freely move on the rod. This end is called as free end. Fixed end. Fixed end must be node. Free end must be antinode. And there are a lot of possibilities because if at all you take the same example, the rule is antinode, so it can vibrate like this. Wait, then there is no rule that it should vibrate only in this way. It can vibrate like this also, because the rule is fixed end node, free and antinode. No? It can vibrate like this also. Or if you go through, you can go for one more also there. Wait. Like this. Understood? So you need to know this one, and remaining parts we'll discuss in next class. Okay.